Hello, my name's Bill Tubbs, and this is a short presentation on the proposed observer for detecting abrupt changes in ore properties. I've been working in production optimization for around 20 years. I started in bulk chemicals and oil and gas in Europe, and since moving to Canada, I've been bringing this knowledge and expertise to the mineral processing industry. A few years ago, I became interested in the problem of optimizing grinding circuits, for example in copper mines here in British Columbia. This is a very challenging problem, as most people know, due to the unmeasurable disturbances and unobservable internal states of the process. The ore feed to the SAG mill, which is the primary grinding circuit, comes from a stockpile which is delivered from the mine, usually via hauling and crushing. The problem is the consistency of the ore feed to the grinding circuit. The hardness and the size distribution is known to vary over time, and this has a significant impact on the operation of the grinding circuit and the downstream process. Until recently, there was little known information about the transient nature of this variation, because it's very difficult to measure in real time. However, recent developments in vision-based online particle size analyzers has shed some light on these variations. For example, the plot here shows the estimated passing size fraction of the ore feeding a mill in South Africa. From this, we can see that there are large abrupt step changes in the particle size, as well as ramp-like behavior. And if we look at a typical model predictive controller used in grinding process control, it consists of an observer which takes the measured inputs and outputs of the process and estimates the internal states, and the model predictive controller uses these estimates of the internal states to control and optimize the process. However, the process is also subjected to unmeasured disturbances, such as the changes in the ore feed. So the ability of the observer to detect and estimate these unmeasured disturbances is essential for effective process control. The plots on the right show the estimates of an unmeasured disturbance by different types of process observer. The standard process observers assume that these disturbances only change slowly over time. So when a large step change occurs, they are slow to respond. And if you try to increase the response time, they become very sensitive to the measurement noise. The multiple model Kalman filter, which we tested in this research, is able to respond quickly to a step change in the unmeasured disturbance. And also it is not sensitive to the measurement noise. The goal of this project is to do further testing and development of the multiple model observers, this time on real data that we received from 2 operating mines, and to verify the benefits in terms of process control and grinding performance. Thank you very much.